In this session, we are going to discuss the operation on Q, and in this session, we are discussing the insertion operation on a Q. In the previous video, we have discussed this particular example, that in a queue we are having a sequence list which can be implemented either using array or one linked list, and there we will be having two variables. One is the front, from where the deletion operation can take place, and another one is the rear, at which end the insertion operation can take place. So, here in this case, when the front and rear is equal to 0 means Q is empty, and whenever we are having this front is greater than equal to rear, that indicates that it is in the linear logic, and whenever we are having front is greater than rear, that means it is in the circular logic. And whenever we are having this, look at this particular pattern, we are having front is equal to 4 and rear is equal to 3. That means the queue is having the formation like this. That means front is my 4 and rear is my 3. So, this is my front, that is the location number 4, and this is my rear, that is the location number 3. So, front means this one and rear means this one. So, it indicates that the queue is completely filled up. Why I am giving emphasis on this particular diagram? Because in this session I am going to discuss insert operation, and in case of insert operation, the check which has to be done is known as the overflow. Overflow means insert operation, but there is no room, no vacant space, empty space for insertion. That is known as overflow situation. So, overflow in linked list can take place in two different formats. Format number 1, when front is equal to rear plus 1. That means this is my front and this is my rear. I discussed each and everything in my previous video. Please watch that one. So, here front is equal to rear plus 1, then the queue is completely filled up. And in another sense, we are having, say, front is equal to 1 and rear is equal to 5, that is the max queue. Here 5 is known as the max queue. What is the max queue? That is the queue size. So, when front is equal to 1 and rear is equal to 5, that means here I am having another 2 data. So, rear will become 5. So, in that case also the queue will be completely filled up. So, in our overflow check I am having two conditions. One, front is equal to 1 and rear is equal to max queue, and the another one is that front is equal to rear plus 1. So, now let us come to the queue insert algorithm and you see. So, algo queue insert, we are passing parameters like q, that is the name of the array, front, that is the front location number, rear, that is the rear end location number, max q, that is the queue size, and then item which has to be inserted. Now, see, if front is equal to rear plus 1, or front is equal to 1 and rear is equal to max q, that means either this way, in a linear way or in a circular way, the queue is completely filled up. So, that is why I put or in between, either in a circular way or in a linear way. If the queue is completely filled up, then print overflow and exit, because the rest part is under else. But in the rest part, this is the rest part which is under else. Now, see, if front is equal to null, front is equal to null means what? Front is equal to null or 0 means what? The queue is empty. That means the first data has to be inserted at location number 1, and that will be the front and that will be the rear. We discussed everything in the earlier video. So, if front is equal to null, then front is equal to 1 and rear is equal to 1. Else, if rear is equal to max q, then rear is equal to 1. I am going for insertion. See here, rear is equal to max q. So, next time rear has become 1. So, if rear is equal to max q, then rear is equal to 1. So, that is the circular logic. Else, rear is equal to rear plus 1, that is in the ordinary case. I am having this rear is equal to 1. So, next data will be inserted at location number 2. The next data will be inserted at location number 3. So, rear is equal to rear plus 1. Q rear is equal to item. Now, I am putting my data at the rear end. updating rear with one of the three conditions and then exit. So, this is a very famous queue insert algorithm. So, what is the queue insert algorithm? That means I should check the overflow condition. What are the overflow conditions? If front is equal to rear plus 1. So, that is the overflow condition number 1 in a circular logic, or in the linear logic, if front is equal to 1 and rear is equal to max q, print overflow, else otherwise I will be doing the rest. What are the rest? If front is equal to null means what? Means q is completely empty. Then front is equal to 1 and rear is equal to 1 means what? That is the first data, that is the first place where the insertion will take place, and that is the front and that is also the rear, because only one data is there in the queue after insertion. So, what is the next condition? If rear is equal to max q, then rear is equal to 1, circular logic. What is the default case? Rear is equal to rear plus 1. So, I wrote everything in that particular sequence, and then q rear is equal to item. So, that is the end of this else block and then exit. So, in this way the queue insert algorithm can be written. We know that there is another fundamental operation can be carried out on a queue, and that is known as the queue delete. Please watch the next video where we will be discussing the queue delete along with the respective algorithm in some C-like format. Thanks for watching this video.